It is given that when a source moves away from stationary observer with a velocity v, then apparent change in frequency is delta n1, and when an observer approaches the stationary source with the same velocity v, then change in frequency is delta n2. So RM is to find out the relation between delta n1 and delta n2. So if you are considering the first situation, when a source moves away from the stationary observer, so we are just considering that there is a source over here and an observer. The source is moving away from the stationary observer with a velocity v. So for the calculation of apparent frequency, we will use that equation: initial frequency into c plus or minus velocity of observer by c plus or minus velocity of source. So over here the observer is at rest, so we can write the equation as c divided by source is moving away from the observer, so that apparent frequency is going to decrease. So we can write it as c divided by c plus velocity of source. So the value of delta n1 is basically difference in frequency. As the frequency is decreasing, we can write it as final frequency minus initial frequency, which is the difference that we can take it as initial frequency was n0, final frequency is n0 into c divided by c plus v. So if you are taking this n0 as common, we can write it as 1 minus c divided by c plus v, which can be further written as n0 into c plus v. If you are taking it as LCM, it is c plus b minus c divided by c plus v. So you can write the value of delta n1 is equal to n0 into v divided by c plus v. So this is the equation for delta n1, frequency in the first situation. Same as like that, we can find out what about the value of change in frequency in second situation. And second situation, it is given that when observer approaches a stationary source with the same speed v. So in this situation, assume that the source is at rest and this observer is moving toward the source with the velocity v. So we can write the equation for it, that is from the equation apparent frequency is equal to actual frequency into c plus or minus velocity of observer divided by c plus or minus velocity of source. So the apparent frequency is n0 into the observer is moving towards the source. So we can write this is basically c plus v0 divided by c. So we can write the value of apparent, the change in apparent frequency, that is final frequency which is more than that of initial. So if we can write final minus initial, final frequency is n0 into c plus v divided by c, and initial frequency is n0. So if you are taking this n0 as common, we can write c plus v minus 1, c plus v by c minus 1. So we can write the value of this delta n2 is equal to n0 into c plus v minus c divided by c, or you can write that is n0 into v divided by c. So that is the value of delta n2. So if you are just considering this delta n1 and delta n2, so delta n1 was n0 into v divided by c plus v, and delta n2 is n0 into v divided by c. So denominator of delta n1 is more, so we can take it as delta n1 is less than that of delta n2.